everyone, and welcome to this series of videos on division. Now, I've said a lot that subtraction is the Achilles heel of all of our students. That's because division isn't even part of the conversation, right? Addition and multiplication tend to get the most attention with our students' basic facts. So subtraction, I find, doesn't get the same instructional time. And so we don't really explore it as much as we ought to, but it connects to the larger numbers and decimals and fractions. So it's a larger issue than just the basic facts. And similarly with division, that we want to make sure that we're focusing in on the relationship between multiplication and division to help us think through efficient ways to be able to get our quotients that make sense to the students and aren't robbed of place value understanding with the traditional long division algorithm. So in this series of videos, I'm making these for our book, Fluency Doesn't Just Happen, with Multiplication and Division with Dr. Nikki Newton and Dr. Allison Mello. This is our sequel to our one on addition and subtraction. In this series of videos, I want to explain to you how we can be exploring the mathematics with each of the strategy zones with division. And I want to begin with this first introductory video to talk about the operation of division. And what is the thinking behind it? What are the story situations we can use to explore this thinking with division? And then finally giving you some ideas within each videos of each of the strategies, how we can actually put this into practical place with our students as we help facilitate their math journey. I have been reading recently Chase Orton's book, The Unfinished and Imperfect Math Teacher, which we all are, and I continue to be. And I love his quote, that we're not just teaching math content to students, but we're helping facilitate their authoring of their math story. And that is just so, so important. As you can see, I'm wearing my t-shirt, the power of yet. That's just absolutely the mindset. I say the word yet all of the time with my work with students as well as educators. So let's get going on exploring the operation of division. Let's begin by thinking about this problem, 91 divided by 7. How would you do that mentally? Now, if you were like me many years ago, before I began this journey of relational thinking and just the in-depth understanding of the operations and calculations that we do in the elementary grades, I would have done the US traditional algorithm in my head. So the 7 goes into the 9 once, and there's 2 left over, which joins the 1 as a 21, and then there's 3 more times, right? But if you gave me a larger set of numbers, I wouldn't have been able to think through it. I didn't yet have that understanding of the operation of division. So what if instead of trying to do that traditional algorithm on our head, we build the understanding with our students that the area model is the best visual model for multiplication and division. So let's imagine if we've learned that multiplication can be represented by a rectangle, that every single multiplication problem, no matter what the set of numbers are, can be represented with a rectangle. Well, I can think about there being a rectangle that measures 7 by something. Now, what math facts of 7 do I know that might get me closer to 91? And it's open for me to decide any math fact. And of course, place value of 10 in our number system can be really handy sometimes. So I know I could make a 7 by 10 rectangle, and the area inside would be 70. So already 70 out of my 91 is taken care of. So now we need to do some work to figure out, well, how much is left in that 91? And there is 21. Oh, and I know that 7 times 3 is 21. So there we go. Now we have a rectangle with the area is 91. My vertical distance was 7. The horizontal distance is 13. And that is what my quotient is. So if I think about division, that the area is the amount within the rectangle, my divisor is that vertical distance. If I figure out that horizontal distance, well, that will be the quotient. And I can use partial quotients to help me on my way. Chunks that are friendlier for my brain that I can use to figure out the answer. I want to begin talking about the 3 basic problem types that involve multiplication and division. The first, I think we're all very familiar with, is equal groups. So we have some number of groups with the amount in each group being the same, equal-sized groups. Now, there are 3 unknowns, though, 3 things that could be unknown. One could be, how many marbles is that in all? So we have 3 bags of marbles with 4 marbles in each. How many marbles is that in all? Very traditional multiplication type problem. But division gets involved when either the number of groups, like the bags in this case, or the number in each bag, become unknown. That's where division can come into place. And the thinking is different from the children depending on which is the unknown. Let's probe a little deeper about this. So how many students solve this if they don't know it? So I give them a context. There are 16 marbles, and they are able to be shared among 4 people, right? A very traditional way of fair share division that we begin with. Well, students might count out 16 objects, and they might be using, let's say, base 10 blocks. Well, they might place out the 16 and then count out 4, circle it, count out 4, circle it, count out 4, and so on until they find out, well, how many groups of 4 are in the 16. But as you're watching them work, you might be finding that their thinking is counting. Now, next level of hierarchy of the strategy would be, I'm going to skip count. So now I'm in this additive reasoning of thinking that I'm going to think, well, I can skip count by 4s, and I can go addition if I'd like to get up and see how many 4s can I get to until I get to my 16. Of course, there would be 4 of them, but also students might repeatedly subtract. They might start with 16 and take away 4. That's a group. Take away 4. That's a group. But again, this is thinking and reasoning first in the counting phase of reasoning, and then additive. We don't want to stop here. We want our students to be in a multiplicative phase of reasoning. So let me 1 second talk about 2 different types of the division and how this is going to translate to the thinking of our students as they begin exploring this in 3rd grade, typically, right? So let's say Catherine has 12 cupcakes, and she's going to share them among 4 friends. This is our typical fair share division. So she has 12, she's going to equally share it among 4 of her friends. We call this partitive division or fair share. This is when the group size is unknown. I know the number of groups. What I don't know is, what is the fair share? What did each person get that was the same as everyone else? Now, I love doing tape diagram models of story problems as well. The research shows how important that is for our students' brains to visualize the structure. One possibility might look like this, where I know I've got 12 cupcakes in all. I know I have 3 friends. What I don't know is how many each friend would get. But I also know that whatever that amount is, it's going to be the same, right? They're equal groups. That affects the thinking of the students when they're given this. They begin in a direct modeling phase of reasoning. So they might place out 12 objects like this. They know there are 4 friends, let's say, if it's still the cupcake situation. I can take away 4 and then give 1 to each group, right? It's a fair share. Take away 4 more, right? The amount of our divisor, and fair share it. And then take out 4 more and give a fair share, 1 more to each person. My pile is gone. So now the question is, well, what is the fair share of one of the groups? And that would be 3. So that the 12 divided by 4 must be a 3. Now that will graduate to larger groupings. Maybe I see the 12 and say, well, I know that I could give everyone 2 and still have some left to share. So they might think about taking 8 from the total of 12 and give 2 to each person. And this could be graduating to multiples of 10s or 5s or other multiples that they know. They then see how much is left to deal with. In this case, there's 4 more, and now can give 1 more to each person. And again, the question is, how much was each fair share? So this fair share way of dividing, kids tend to take away the total amount and then fair share it between the groups. Now, the other meaning of division is quotative division. This is when I know the size of the groups. I don't know how many groups it's going to be. So if Catherine had 12 cupcakes, it might sound like this. She has containers that fit 4. How many containers would she need to put all her cupcakes in a container? Well, this is going to be, I know I can have each container having by 4. I might count out by 4. I might skip count by 4s, but I'm figuring out how many groups of 4 are in 12. This is called quotative. It's like measurement division. So this would be very familiar with, if I give it context of I have 12 feet of wood and I'm trying to cut them into 4 feet pieces. How many pieces could I cut? Is that we know the measurement. This is the size of the group. We just don't know how many groups it is. It does encourage repeated subtraction. And it's when the number of the groups is the unknown. Here is an example of the tape diagram of this story situation where I know each group is 4. What I don't know is how many groups is it. So container 1, container 2, container question mark. That's what I'm trying to figure out. Now, this corresponds to the thinking where I take 4 away from my 12, but I make one group. And I take 4 away and I make another group. And then I take 4 away and I make another group. So that thinking is I'm taking away that amount, but I'm making it into a group. There's no fair sharing happening. So different thinking, having us be aware of the different contexts and how it can help students as they're thinking through. So equal groups is one big, probably the most frequently that our students are encountering. We also have arrays where there are actually rows and columns, and each row has a equal number. And again, we have 3 parts that could be unknown. We have the total amount in the array, the number of rows, or the number in each row. And of course, the area model is the measurement version of arrays. And so we have the length, the width, and then the product, the area inside. And lastly, we have multiplicative comparison. This is a harder problem type. It tends to be introduced in grade 4. And it's being able to think about 2 quantities, a larger grouping and a smaller grouping, but the larger grouping is literally a certain times amount of the smaller group. So if I have 3 marbles and Jen has 3 times as many, she has my number of marbles 3 times. So it's an iteration of that smaller group. So you might be figuring out how many times more is the larger group than the smaller, or we know how many times more, but we're only given the smaller amount. We've got to figure out the larger, or we know the larger, we're trying to figure out the smaller. So this multiplicative comparison, again, sage for 4th grade on up. The really important piece of the puzzle with our division and with the math facts is what happens in the moment after a student has tried to retrieve a math fact from memory and it doesn't pop into their mind. What is their thinking? So I always prompt them with, how do you know? What did your brain just do? Can you prove it? To see what is the thinking that they rely on to help figure out facts that they don't yet know. And keeping in mind this amazing graphic by Pam Harris based on research of what is the development of math reasoning. Right? So our kindergarten kiddos, birth to kinder, they're in that counting phase of reasoning. We help them move into additive reasoning in grades 1 and 2 when they're doing adding and subtracting. But in our 3rd to 5th grade years, we're helping facilitate their movement into multiplicative reasoning, moving beyond the skip counting and using multiplicative reasoning, which is where division fits as well. And so here is a trajectory. I do have this on a Padlet, which is a web page full of resources for you. Our math running record one that Dr. Nikki and I have on that math running record, the interview protocol for interviewing students about their thinking. Here is the division progression, how students begin by counting everything. It's called counting all in the research. Then they go to skip counting, but how we want to help move them into multiplicative reasoning when they don't know a math fact from memory. Of course, our goal is to have all of our students get to that mastery point with understanding, right? But it's a journey to get there. As Dr. Nikki says, fluency doesn't just happen. It's a well-planned journey, right? So let's think for a second about this quotative division and how we can help facilitate this movement into a way of thinking that is that multiplicative reasoning. So here's an example of 27 divided by 9. I love Cuisenaire rods. They're my favorite manipulative. The numbers are existing as a group, so it helps the students move away past the counting one by one. You're seeing on top a distance of 27. Those are 2 10 rods and a 7 rod, so 27 units long. And beneath it, I've put that quotative of 9. So I'm dividing by a 9. That's the size of the group. So I put that down below, and you can see that I have 3 of them. So what I have my students do is to move them then into an area model. So we want that divisor to be the 9 going down just as a convention. It's not an absolute rule, but I do like following this thinking. It's helped me visualize this. So we know that the area is 27 because it matched up with the area of the top with 2 10 rods and the 7 rod, right? So if I know the area is 27, and I know that the divisor is 9, we can imagine it looking like this, that our job is to find out what is that horizontal distance, because whatever it is, that is the quotient, right? And so I could be thinking about however I get there to figure out that it's a 3, that's going to be that quotient. And so this model here, if you think about the symbol for division, goes right along with this model. We have the area inside the rectangle. The divisor can be that vertical distance, and the horizontal one is that quotient. So how can we use this thinking to help our students with the math facts? Well, we can use facts that they already know. So 40 divided by 8, I can connect that with a visual representation of the area model. Maybe I know 8 times 5 is 40. So I can be visualizing this rectangle. I know 8 by 5 makes an area of 40. So when I'm asked a question like 48 divided by 8, I can ask the student, what math fact of 8 do you know for sure? What amount of rectangle can we do, that area that can be as close as we can, whatever you know, but it's built on whatever they know, right? And so maybe they know that 8 times 5 is a 40. Can we use that to help us figure out 48 divided by 8, right? And so, yeah, it's 1 more 8. So that total distance must be a 6. This is an example of a number string where we can be stringing together this connection to help our students see that I can derive facts I don't know, but using one that I already do know. A lot of students know that 8 times 5 is 40. So let's capitalize on that knowledge. Similarly, a 56 divided by 8, if I don't know what that is, no numbers popping in my mind, well, what do you know? I know 5 times 8 is 40. How many more do we have to go? Well, 16 more, which is 2 more groups of 8. This, I think, is the key to the thinking for our students, to be able to derive these facts they don't yet know from memory on their way to developing that mastery with understanding. The research very heavily shares that the thinking for our division facts relies so heavily on thinking multiplication. So when I'm asked 45 divided by 5, the first thought for our students ought to be, well, 5 times something is 45. Do I know what that is? So if they have been working on multiplication math facts and they've got those down in their minds with that mastery, right, that they can retrieve it relatively quickly, then we can connect that to the division strategies. The problem comes into play when they can't retrieve from memory what that fact is. So what is going to be their thinking? And we can help them with that area model to think multiplication. So if I were to ask a student 48 divided by 6, if they don't know offhand what that is, I would say, well, how many 6s do you know for sure? And then we can put that as on grid paper as a model of what their thinking was. Maybe they know that 6 times 4 is 24. Now, if that's the case, then how many more do we have to get to make an area of 48? Oh, it's just another 4. So I can help them to be making their thinking visible to us by having used the 6 times 4. Maybe another student says, well, I know for sure 6 times 5 is 30. We can then make that partial quotient and then say, well, how many more do we have to go? In this case, 18 more, which would be 3 more groups of 6. And another student might say, well, I know 6 times 7. I've learned that that's 42. So we can help them derive this fact. But this is the multiplicative reasoning that we want to be encouraging with our students. This is moving past the skip counting. Now, another strategy can be halving and halving. So learning through experience that the way we can work with our numbers, sometimes we can change the numbers, but still have it be efficient for our brain and get the same answer. So as we are exploring this with students, we want them to be able to realize that a 42 divided by 6, and if I half the 42 and I half the 6, I'll be getting an expression that has the same answer, but they're using numbers that might be more friendly for my brain. Maybe I know 3 sevens is 21, but I don't know is 6 sevens is 42. But I can be using a fact that I know to help me derive that. Similarly, a 64 divided by 8, if I don't know that, but I do know that there's a relationship that I could half and half, and then I could even half and half again. Oh, I could even actually half and half again to get 8 divided by 1, right? So there's no limit there when you have those, the doubling numbers, right? 1 to 2 to 4, 8, 16 and whatnot. And so being able to use that number sense to be able to change the numbers to be easier for my brain. I have that, I'm empowered to do that because I understand the relationships involved. Now, I love Jennifer Bay Williams. She and John Sangiovanni wrote a wonderful book called Figuring Out Fluency. And I love how she says that students need to know how to use a variety of strategies so they can eventually choose to use them. Right? It's not about us telling students you must do it in one certain way. They need to know a variety of them and how to use those variety of ones so that they can choose ones that make sense with the numbers. Here's an activity they suggest that I love, where you make up several expressions and say, well, which ones of these, for example, would the half and half strategy work well for? Right? And then now they could work for all of them, but some of them, when you half and half them, you get decimals or fractional amounts, and that's just not super easy to deal with, right? But there are many of here that maybe if I don't know the fact from memory, I could be thinking about, well, let me half and half it and see. Now, of course, having is a fundamental skill our students need to be able to do. So if we have, for example, the 36, when I half that, I have to know about the half of 30 is 15 and then half of it is 6, right? So that might not be in a comfort zone yet for some students, but for example, a 48 divided by 6, well, 48 can be relatively easy halved to 24. So I can do 24 divided by 3, right? It's about the comfort zone at this point of our students. Of course, it's all about the students using what they know to help them derive what they don't yet know. And that thinking is that crucial piece. Can they be using multiplicative reasoning and relationships to be able to derive those division facts? So now in these next set of videos, I'll be going deeper with each of the strategy zones of how we can explore these concepts with our students in ways that make this thinking visible and encourage them to move into this multiplicative reasoning.